questions, right? Since I don't see the video, I do not know whether you are doing it or not. So I want all the teachers, faculty members in the respective classrooms to keep all of them on, right? So we have to do things together. That's how we learn stuff. Okay? Great. Having said that, so last class where we left off was we were talking a lot about the work. That's where we left off. Then I gave you a small exercise. Somewhere here exercise, right? Change the program to list of 4 elements. So, as these DMS and CSC girls are integrating the video, show of hands, how many of you have traced the program with the list of 4 elements? Who has traced the program? Because that can be posted separately, right? Okay, zero hands. So if you had code there, so today I'm going to pick on it because so we gave the full program there. I gave you highlights of the program and I asked you to trace it. So I expect you
hey,
so now come to the faculty members there who are your mentors to ensure that you are doing what they ask you to do. Okay? Okay. Covered the factorial also. Again, I give you full code of factorial computation there. Right? This is all full code. We did some tracing here. Right? 1, 2, 3, 6. We took the example of factorial 3 and I traced it for you how this is being done. Okay? Again, if you don't quit, have to be brutally honest. If you don't do it, right, the problem is not mine, the problem is yours.
speaker bani
This part as a faculty member. I can't make you do it because you're not here, right? If you're here, in class everyone is
సరే ఇది కూడా 30%
so your faculty members there who are coordinators should make it happen. Okay, so today's focus would be a couple of additional things to wrap up into, right? One is post-fix notation. So we need to understand classic computer science algorithm, right? Given in fixed notation, we convert them to post-fix notation. And then we compute until we complete the post-fix notation. So I gave you some examples in the classroom just when we were wrapping up. I don't even know if I wrote my post-fix notation correctly. I asked the faculty members to verify whether what I have written is correct or not. But no one responded. So when I considered formally, I mentioned to you last time, I said we will formally in this class. So we worry about post-fix notation. How do we transform from fixed to post-fix? So these are all these stack applications. These are exactly the type of questions
speakers are not good. Some speaker problem.
Yes, some program to campus. These are the questions we will be asked as compared to this.
There are any speakers English number.
We'll do that. We'll also talk about queues. And give the foundation for the queues, including the algorithms for our risk.
Suspended.
One is to simplify queues, each type of data structure is another. That's where the actual fun is. These are the two things that we're focusing on. These are applications of queues, and these are foundation for application of queues. I will not give you the experience of it. I expect you
Bidden or money?
to know the heroes things and discuss having said that, here is the post-fix notation.
Okay.
Now, if you have any questions, you can put it in the chat.
Laptop is pension.
So here is the post-fix notation.
Sorry, compare it.
Another term for that is the reverse Polish notation. It came after a Polish mathematician who gave
I think it might.
notation things like that long. So one Polish is the operation and function followed after. So, and here is a simple example here. One to add would be post-fix notation for adding the numbers 1, 2. Because it gives the operands first, that is 1 and 2, that's called operands. And then we are saying what we need to do with this operand as a function input.
Thanks, Indy.
So, here is one example.
And these are
And we're doing some quick hands-on exercise. Right? So, we have the example 1, 2 plus 3 star 6 plus 2 plus 6. So what will it be? 1 and 2. Right? You are traversing from left to right. Right? And then you have to get left. What left is 0. Take the 3 is 2 operands. That's 1 and 2 and 1. So 1, 2 to result is 3. Then you have 3 followed the answer 3 and star. So that means you are going to multiply. See the slide. 9 is 6 plus 8. And the 2 previous numbers, 9 and 6, 15.
1 and 2
Right? Then you get 2, 3 plus 2, 3 is 5. Right? So you have 9. You have 15, 5, 15. So you divide by 5. Done? That is what it is. Have you learned post-fix notation in your computer science program initially in introductory class?
Multiply with 1 plus 2. 1 plus 2. 26.
The same expression you can see actually which is the one that we have that is a standard algebraic expression, right? So we all
ఇది ఇక్కడ దాకా ఒకటి ఇక్కడ నుండి యాడ్ చేస్తాం ఈ రెండింటిని డివైడ్ చేస్తాం
So you can see that you put a lot of parameters, you put a lot of parameters to show which order the operations have to happen, right? So in terms of operation precedence, I think we know that parameters, you evaluate the expression of parameters first, right? Then star is usually the next level of precedence, followed by plus 1. So by evaluating this expression, you will get the value. Post-fix, the first bullet here, there are no parameters. So I want you to notice that. And then you have prefix notation, equivalent of that, you can see how prefix means the operator is coming before the operand. Infix means the operator is coming immediately the operand. Post-fix means the operator is coming after the operand. It is not intuitive at all. When you do the prefix and post-fix, it's not intuitive at all. People have widespread even as we start remember they have different understanding that, right? So they are not used to it. It's not intuitive. It's not intuitive by
green lines
then for computers, it's much easier to compute 4-6 rotations rather than 6 rotations. Again, when I make those statements, technically the students may not appreciate it. I do not know when you take compilers class. I don't know if it's coming to the third year or second year, second semester, third year, whenever, right? You will see when we run compilers, we do what is called the parsing of the statements. So we see the computer statement one by one by one. So it is a bit more challenging for the compiler to understand because it's not that's what happens in the case of exploitation. If you do postfix, then it's very easy for compiler to figure this out. And most important thing is actually also saves time in terms of performance of the program. No more parentheses, right? Number one, the number of tokens, each of those things, each parenthesis, the signs, minus by and all those things are called tokens, right? The number of tokens in a postfix, especially the number of tokens. So the number of tokens processed is faster. So that is a code. So if I give you the example here, 5 plus 6 factors, that is the rotation, right? So what is equal postfix for that? I can't make it simpler than that. If somebody put in the time, what is the postfix for that?
software install of the driver.
For the next one. Notation 5 plus 5 times 1 plus 2 times 4. What is the postfix expression for these two cases? What fact is given by students or faculty?
ఇక్కడ అయిపోయింది తర్వాత ఖాళీగా వాల్యూమ్
Okay, what about for the second one?
Hardware problem అవ్వచ్చు లేకపోతే లోపల డ్రైవర్ the driver compatibility driver software driver అది మాత్రం కరెక్ట్గా ఇన్స్టాల్ కాకుండా లేదు. ఫంక్షన్ రిఫ్రెష్
వాల్యూమ్ చేసిన ఫుల్ వాల్యూమ్ బాగా తక్కువ వస్తుంది
ల్యాప్టాప్
I do see team and they are working on it. That's good. I'm encouraged. So you start the page that is the answer for post. First one is not doing it because you already got it. Pretty interesting, huh? It's fun. Then you have 5. We add 5. Then we do is 3 minus. Refund. Now, the trick is right. The syllabus says you need to know how to write a program or algorithm to convert an infinite notation to postfix notation. If you took that one, and then you convert it to postfix. How do you write the program? What is the data structure? So here, if an operand is encountered, that means the data or the next parameter is encountered, pushed it onto stack. Because parenthesis expression has been first. If an operator is encountered, then it will be formed from the stack and add to each operator. Because remember the moment, that's exactly what we have done in this one, right? The moment we see an operator, we are always taking the previous 2 operands and performing that operation. Okay? And then like that. If a right parenthesis is encountered, then repeatedly form from the stack and add to each operator. So there's some algorithm like that. It's all Greek and Latin, right? So it's very hard to understand unless you trace. That's why right and K1 and the key trace. Algorithm we don't start this like that. It's not exactly right. After you did it once, then it will try. But usually as a team, no one is very valuable to write the such time, okay? Unless you are a division. Okay. So here is the slightly bigger one. What are we doing here? Suppose to use an arithmetic expression. There is equivalent postfix expression by adding items 2 on the right of
Then remotely
the expression will not contain any parameter. The postfix will not have any parameter. Okay. So you're starting with an empty stack. Okay. So there is nothing there. What we are doing here is this typical pseudocode, right? Why we have not extended it. If you find an operand, push it to P. That means P is another stack. Okay? So left parenthesis form, push it onto the stack. The right parenthesis form, and while the stack is not empty, the operator is not a left parenthesis, keep popping and add the value to P. So like that you have the rest of the code. Again, I am not asking you to understand the code on the slide there. Unless you treat it, you don't understand. So we come back to that, right? So I give you how we do this, because remember that we have each stack, right? So I give you a piece of code here. This code only takes care of operators plus minus star division, percentage modulus, atomic sign and exponentiation, right? Parameters. First thing, we need to declare a struct stack, because we are building two stacks. The stack has two things, right? The top. Now you are familiar with these things called initialization of stack, empty stack, full stack, top stack, push stack, top stack. 2 other things that we see new which are new to use. One is called precedence. And the other one is infix to postfix. That is the actual function which performs the infix to postfix execution. Okay. Let's look at that, how that happens. Okay. So
The Bluetooth device is ready to pair.
One, top, and all of those. Did I do that? The picture. I didn't do that. So here is the
The Bluetooth device is ready to
code there. Okay. Again, you would not understand what it is, so I'm going to use that. So, one of the things that you can see from this slide here is, so look at the P here. What are we doing? We are declaring an array. Remember, stack is declared as an array. the 34 bits of data. We declare an array of 30 elements. And then what we are telling them, okay, enter the expression as a string. So whatever expression, then we do get s of input. So we are saying that it's big whatever you are entering, the string. Now what does get s mean? In C programming you would have learned that, right? Get s is nothing but getting the string. Whatever the user has entered as a screen, you are reading that as a complete string. In C programming you would have learned that. Now where is the string saved? The string is saved in the array called input. I mean, ideally you enter the string which is less than 30, right? If you enter more, then the system will give an error. Maybe, we don't know that. In C does not have automatic buffer check. I don't know if your instructor told you any of these things or not at that level, because it's an introductory class, right? So you can check, for example, when you are running this code or testing this code, you can actually give a 50 character string and see what happens, right? But now let's assume that it is given correctly. Okay. After you get that string, then you are calling the function, hey, here is my starting string in 6, put the value in postfix. That is why you are setting in 6 and postfix. It's a function call. Okay. So when you come to function call here, we switch to postfix. I'm now on the right side of the screen. Okay. So what are we doing here? First we are declaring stack. Okay. Then you need some variables which are character x and token. We'll see what those things mean here. Okay. So initially what we are doing, we are initializing the stack. That is init. We are passing the address of stack. It's going to be initialized. Okay. We'll see what the init function is in a minute. Then you have some kind of a initialization here. Sorry. So you say for I equal to 0, you fix I not equal to /0, I plus plus. So you are now reading each of the elements of the infix array. You get that? Right? We have to convert that, right? We have to read each and every element of the infix. Now, can anyone tell me? I mean, you will earn a lunch from me here. I'll tell you, faculty wants to give a lunch coupon. Can anyone tell me why in the for loop I have written infix I not equal to /0? Who can give me an answer for that? Just a simple first statement. Where did we even get that forward /0 there into the array? Where did that come from? I'm basically testing your C programming language there. Anyone knows why we said infix I not equal to in quotes /0? Why did I not say for I equal to 0 in 6 or I less than or equal to 30? I could have done here. If I go here, could I have said could I have said I less than or equal to 30? Is that still a correct statement if I say I less than or equal to 30? CMS, SVCIP, SVCIP, your video. Tell me, show of hands, do you think it is correct? I less than or equal to 30? Who thinks that is okay too? You can raise your hand if you think it's okay. Don't be shy. But it's right or wrong, I don't care, right? Okay, tell me, show me your hands if you think that is incorrect. Who thinks it is incorrect? Raise your hands if you think it is incorrect. You have to raise hands for either one of those things, right? If you think it's incorrect, you raise your hand. So So since nobody is raising hand, that means you think it is correct, right? So if it is correct, then raise your hand. Okay, I kind of see one person trying to raise half the hand. Raise it fully like this. You can raise the hand like that, right? All the way to the top. Can I You're laughing. Okay. It's fine. Why not I less than or equal to 30? It's not programming, right? It's fun. The reason why we don't want to say I less than or equal to 30, right? It goes back to getS, right? If you understand getS, what getS does, when it reads the string, how does the compiler know the string is always terminated with a \0? You probably forgot that. So when it is reading a string, after it puts it in the array, okay, question is not clear. Okay, now that is classic. Question is not clear. Okay, thank you. The question is, as you will control the first let's go back to my original. So I have the for loop here, right, like this. Okay, let me put the for loop in the chat. Listen to everyone. That is the for loop given in the program statement, correct? Then I said, is that why did we say int I not equal to \0? That was the original question. I asked somebody to answer that. Okay? Instead of doing int I not equal to the count \0, could I have done int I less than or equal to 30? Could I have done int I less than or equal to 30 in the for loop statement?
ఇందులోనే పెట్టేసి
Might give some answer. We do not know whether the string, the array is completely occupied or not. And we do not traverse all the way, because it will all be empty. The program will still work. We are going to need some cycles of computation. So the entire array is not filled up. However, C programming has a beautiful structure called getS. That is getting a string. Strings by default know that by definition strings have a \0. That is a terminating symbol for string. When you learn strings in C, they probably would have taught you that. So that's the reason why when you read that string getS, when it saves in the array, the last character in the array would be the \, the termination string. Okay. Since we already know the termination string is \0, we are able to use that in the first string. For I equal to 0, int I not equal to what this thing is. Since the string is not terminated, continue to do that. Okay, so we'll leave it to that. Let's move on. So, first time we are there, okay, because we put some string, token equal to int I, so we get the first character. Okay. Once we get the first character, we are going to check is it an alphanumeric. So this is a system generated function. Is alphanumeric, if you look at the library, C library, it checks whether it's an alphanumeric token or not. Okay. If it is, then we are saying put it in the postfix array. Okay. Else, if the token is an alphanumeric with the left parameter, okay, let's push it. So like that, you are building your structure. So go through that. You have the test code, go through that, and then you will have to convince yourself that program works, right? I go through each and every line. It will take me 1 hour. I just continue that code on the next page. Okay? And then you can see the precedence here. Simple operators are the precedence, right? So if you have left parenthesis, then you do something. If x equal to plus or x equal to minus, you do something else. So depending on the operator precedence, you have to take the action accordingly. Okay? Now, these functions are pretty familiar to you, right? We covered them earlier too. How do you check for empty stack? Let stop equal to -1 because that tells you that the stack has not been initialized or it's empty, you return 0. Let stop is max -1, then the stack is full. Now you know how to push the element in stack. I give you all these pieces of code in the last couple of classes. It's a push. And to get to the top of the stack. Top and top. Okay? So that is by doing that, here is a trick for you to know what is happening in the code. Okay? So that will be nice and video on the trace also. So what are we doing here is this trace. Let me go up here slightly. Let me adjust my screen. So here is a trace of the code, how the stack structure is working. So here is the input expression in E plus C star C minus B parenthesis division by E. Okay. So as you go to the code that I gave you, you can see initially you have nothing but empty stack. 1, step number 2, here is G, you got a A, so that gets pushed, then plus. So you can see how the stack is getting released. Okay? So that is a trace. So by doing the trace, you will see how the code is getting executed. Okay? Now, you might ask me a question. Will we ever write this piece of code as a programmer? Scientifically, you would not write this piece of code once you are in industry, right? Because all these things have somebody has already written them, and most of these things are actually saved in the C programming library. Okay? That's why we make use of the library. It does not mean you should not know how to do it. This is where, as an undergrad student, you are developing your skills of algorithmic development. Okay? That's the reason why we teach you these things. That's the reason why they ask you in the interview also, how would you do this? So you need to understand these things first, passing an interview and getting the job. Once you get the job, they will never ask you on a project to write something to reverse a string or convert from a fixed to postfix, because all those things have already been developed. Okay? Good to know that. Okay, so that is converting from infix to postfix. Okay? We are not done yet, right? Now the main goal is you want to evaluate arithmetic expression, right? Remember, you wrote a lot of arithmetic expressions in C programming. The compiler magically gives you the answer. Or rather, the runtime environment, compiler will compile. It doesn't give the answer. The runtime executable is what is giving the answer. Okay? How it is done internally is what the evaluation of arithmetic expressions using stack is all about. Okay? So, the way the system works is, it actually converts. I'm not going to each and every line here, but I'll tell you what it is basically doing is, it is converting the infix expression to postfix. Okay? And the postfix expression is on the stack, and then it starts reading the question that I showed you at the very beginning of the class. Okay. In the process of doing at the end of the computation, you will see only one element left on the stack. Okay. And that one element on the stack is the result. Okay. So I give you a piece of code here if I'm not mistaken. Okay, I did not give a code here, I don't know. Yeah, I gave code, but forget the code here. So, here is the exercise I want you to do for the next 7 minutes, okay? So, how does this really work? So, we are going to see that here, right? So, I'm giving you a postfix. I'm asking you to create an empty stack and start scanning the postfix expression from left to right. Okay? So I'm already giving you a postfix expression that is there on the screen. Okay? Create a stack. I showed you how to create a stack, right? Stack is nothing but like this. 3 lines like that, right? A bucket. Stack is nothing but a bucket. Draw it in different places, not on the same stack, okay? See how each of the stack are built for each of these things, right? So use that similar diagram. Okay? If the element is an operand, push it onto the stack. If the element is an operator, go pop twice and get A and B respectively. And then you calculate B of B operator A and push it back onto the stack. Okay? So when the expression is ended, the value of the stack is the final answer. Everyone understand the question? So I'm giving you the expression. I'm asking you to follow the steps given above to build a stack trace. Okay? Ready, set, go. You can take 5 minutes. It should take more than 5 to 7 minutes. Faculty members, please facilitate in your respective classes. If your video is on, turn it on so that I can see all the wonderful students working on it. Okay, I'll get myself another cup of tea when we are doing it, okay? Time now is 11:45. 11:45 is for you, so do it for 11:57.
ఎలిమెంట్ చూసుకో ఎలిమెంట్ నెంబర్ అయితే స్టాక్లో అదే ఆపరేటర్ వచ్చినప్పుడు 6 నిమిషాలు కాప్ చేయి తీసేసి యాడ్ చేసి ఉంది నెక్స్ట్ది ఆపరేటర్ కాబట్టి దీన్ని తీసేయాలి
Good morning, Jntuk Moocs. So can you hear me? Hello? Yes, I can hear you now. I can hear you only. That's a nice, wonderful pink shirt that you're wearing. Is it pink or red?
So some kind of multicolor. Who's playing?
Multicolor. Hi. Okay. I'll mute myself once they're doing the exercise.
Okay.
Enter. ఆ రిమోట్తో నొక్కి జరపాలి. ఆ కెమెరా జరపాలా ఇంకా నెంబర్ అయితే స్టాక్లో ఆపరేటర్ వస్తే ఈ స్టాక్లో 2 నెంబర్లు తీసి ఆపరేటర్ రిజల్ట్ వెళ్ళిపోయాడు.
Tracing part. Not necessarily the answer. Answer also is important. Did somebody trace it too? Okay. I have 2 different answers. One is 4. The other one is 6. So let me put it to everyone here. So I have 2 answers so far. Somebody got a 4. Somebody got a 6. Somebody wrote that they changed it. Okay. Changed it, okay. Why don't you hold it against the camera? You can see your trace. Focus zoom chegastara మీ అక్కడ coordinator or the video cameraman. Or of course you can take a snap with your cell phone, email it to me and I can show it on the screen here. That might be the answer. You have my email, right? pratap@letso.com. Just take a screenshot of it. Technology is wonderful. Just email it to me and I can show it to you. What is the answer that you got? You got 4 of course. Somebody got 6. So one of you is right, one of you is wrong. Okay. How are others doing? EMS? I think it was EMS who put the answer. I'm not mistaken. Retreat. Yeah, EMS gave the answer. You can fill the trace too if you want. Okay, we can collectively see what the answer is, tracing. So, now whatever you trace, right, what you need to do is, right, after the class, on the class floor we may not have time, is, I'm giving you the code, right, how to do it, the actual code I give you there. Take that same expression, trace it through the code. ఇక్కడ మనం ఊరికే algorithm stack to చేస్తున్నాం. But ultimately I will trace it to the code. So once I upload the code into the community, trace it there. That's how you learn, how you will understand what the program is.
The Bluetooth device is ready to
Fantastic.
pair.
Now,
Line in.
and the way we got it is, so as I traverse through this one, right? I'm traversing left to right. I see 210 plus. Okay, the moment I see plus, that will get converted to, if I were to write it here. So maybe it takes from 3 and you get 4. Got it? Start accurately. Did I put a star anywhere? Yeah. Okay. I know it's not. Okay, it's actually plus. Okay, got it. Okay. Understood. But you got a hang of it, right? How to do it? That's the fun part. Now, same thing you apply to the code and then convince yourself the code works. Okay? Okay, let's move on. That's fantastic. Do I have any more hands-on today? I think I do. Let's go. I'm encouraged today. More interaction. So I actually gave the code here. You can see here. Made and then integer evaluate character. Okay. Which slide I'm on here? Give me a second. I lost my train of thought here. Okay. Okay. I gave the init stack, push, pop, pull, all that is there. Okay. We'll not trace it now. We'll trace it if there is time at the end of the class. We'll trace it in the class. Okay. After I'm done with the queues. Okay. Then you can trace the code. I'll actually post in the community also now. Okay. Let's talk about queues. Okay. Okay. Anyone who does not understand, the easiest way to answer this one is there anyone in the classroom who does not understand what a queue is? You stand in a queue. By the way, in US we call them line. Huh?
Volume down.
When you go to
2 seconds,
supermarket, you are in a queue, right?
Line,
when you go to movie theater to buy tickets, you're in a queue. So queues are everywhere, right? So I don't need to tell you what a queue is. But what are the properties of queues? Okay? That is what is important, right? So let's look at it formally. First of all, it's an ordered group of homogeneous item of elements. Okay? At least from a computer science viewpoint, that's all homogeneous. I know in India we will have lines where lines, not only human beings, but other things to stand in lines, you know. You have so many things, like if you go to the temple in Kashi, the Kashi Vishwanath temple, I was in a line to go through. Line stretches onto the street. In the line there are cows, dogs, everything is there. Okay? Non-homogeneity, but we are not talking about that here. We're talking about an ordered group of homogeneous items. Unlike a stack, queue has two ends. Okay? One side you are adding the elements and on the other side you are removing it. Okay? You can see the picture at the bottom. Okay? That is very important to note. Okay? Now the element added first is also removed first. That's why we call it FIFO, or first in, first out. Okay. That is what is known as. So element vector, so the head of the queue in this case 1 is what the first one that entered the queue, and that is the one that goes to exit also. Okay. So that is the basic notation of a queue. Okay. Now what do we do with queue? Just like in stack, when we introduced stack, we said it is a last in, first out, right? Unlike first in, first out in queue, stack is last in, first out. And there's only one side where you can push and pop. Those are the basic operations, and we also include the basic operation called top. So similarly, queue has certain set of basic operations. So let's look at what those are. So a couple of things here. So you will first of all have some maximum number of items. Okay, that might be on the queue. When you build queue dynamically, then there is no max, right? Max is only limited by the computer memory. Okay. The item type is the data type of the items in the queue. And then these are the operations that you can perform. Okay. Is it empty, or you can make the queue empty? Is it full? NQ. NQ means that this is like a computer, we are adding an element to the queue. Okay, that's what NQ means. DQ means you are removing an element from the queue. Okay? Very fundamental concept of queue. We'll see examples of it. It's there all over the map, right? Now, similar to how we did the stack, let's look at how what kind of things we do for queue here. So NQ. NQ means adding new item to the rear of the queue. Remember that? Rear of the queue, not front of the queue. What is the precondition? Precondition is same thing. We did similar thing for stack. Queue has to be initialized and is not full. Those are the two conditions, right? This is, by the way, this is a good internal exam question, right? They'll say, list the precondition and post condition when you have to add an element to a queue. So you should understand what are the prerequisites or preconditions. Post condition, new item is at the rear of the queue. Okay? Again, simple stuff. For those of you who are watching the number of slides here saying, oh my God, it's 93 out of 102. Oh, we'll be done in another 5 minutes and that's it. The class ends early and we can go watch a movie. You might think like that, but I always leave room at the end for you to work on the problems in the class. Okay, don't get too excited yet. Okay, DQ. So removes the front item from the queue and returns the item, right? Now obviously precondition is queue has been initialized and is not empty because you cannot remove anything from an empty queue, right? Okay. So post condition, front element has been removed. Okay. And then you have to, technically speaking, and say, then the next element is going to be the front element. So you move the pointer there. That is what the DQ is. Got it? Very easy, right? Concept is easy. Once you get to programming, that is where the tough part is. Now queue, just like stack can be implemented. Remember when we looked at the stack, we looked at it two ways of implementing it, right? One is linked list, the other one was array. And when we use a linked list and all, by default we use pointers. You know that. You have seen enough code samples that I have shown you, right? Same thing with queues also. You can use array, you can use linked lists, pointers, structures, anything that makes sense to you. Okay? In general, once you become a proficient programmer, we don't use static stuff like array, because array is fixed, it has limitations. We typically generate memory, we allocate memory, do malloc, okay, and then start building the structures. That way we are not limited by the declared array dimension. Okay. Now here are some code snippets. I call them code snippets because I did not give the full-blown code, right? I didn't say Found include stdio.h and all that. I just took bits and pieces of the code. So peak, what is peak? Peak is an interesting thing where we are saying we want to know what is at the front of the queue without actually removing it. So we click peak. So you are not removing the element, we are just looking at what that element is. This is like the reason why you want to do that is when you learn compilers or operating systems, you will understand these things better. There is something called a look ahead feature in order for me to perform certain functions. So peak could come in handy in those cases. Okay. Now, just like in stack, we want to check whether it is full. Is full. Okay. And how does that code work? If rare, because rare is pointing to max size minus 1. Remember, the reason why I always do max size minus 1 is the numbering starts from 0 for us, for computer scientists. That's why you always say max size minus 1. If array equal to max size minus 1, that means this is full. Okay, if the array, if I implement this as an array, and array is 30, max size is 30, and 30 minus 1, that means I filled up all the array cells. Then it will be full. Boolean is empty. This is great. This is interesting actually. For a second it was counterintuitive to me as well when I was putting this. If front is less than 0, that I understand, right? Because when you initialize it, it's a minus 1, right? Remember, even in stack we said variable initialized to minus 1 to show that stack is empty. If the front is less than 0, yeah, there is nothing there, it's an empty queue. But why do you say front greater than rare? Even then we say it is an empty stack. Can anyone tell me why that condition also is required? Front is greater than rare. Return true. So you are implementing, let's say, Q as an array. Right? Checker, please feel free to help me out. I could not figure out, at least maybe I did not have enough key. Front greater than rare. Do we need that condition to check whether the queue is empty or not? Any faculty member can help me on that. Students, here is a classic case that I am saying, hey, I am teaching, but I am saying I am not able to figure out why I need that condition, front greater than rare. So actually, help all of you, including students. So if I have to visualize that one, right? Let's do some fun things, okay? Let's say if I have to visualize an array, if I create an array, one dimension. Okay? So this is my array. Let me create this. Let me give it copy it. Control X. So this is a cube. Let's call this one front here, okay? Front is here. This is the front element, okay? And this is the rear element. So if I say rear. So I'm saying Q is empty. No. So front greater than rear. When will front become greater than rear in this code? Does it ever become greater than rear? I was not sure. Should I pass the ball to you? Am I audible? Hello? మీ వాల్యూమ్ లోగా ఉంది కొంచెం గట్టిగా మాట్లాడతారా?
సార్ ఈ ఫ్రైడే మేబీ మనకి హాలిడే ఉందా సార్?
హాలిడే
వరలక్ష్మి వ్రతం ఉంది. It may be an optional holiday, but I think some of the colleges they may take holiday on the Friday.
Oh no, okay. So we cannot,
Tomorrow can we have class, sir?
yeah, we can, tomorrow is what, Monday night, that week, yeah, we can have class tomorrow.
9 to 10:50 and at 10:40. First hour.
9 to 10:40, yeah, done.
So I request all the colleges to adjust your timetable according to the link. Tomorrow we will have this DS class from 9 to 10:40.
What about one additional class where we want to compensate before the internal exams?
Friday, Saturday and Monday we cannot have any class. Most probably again next Wednesday we will have another class, compensation.
Okay, internal effective start over there.
Yes, sir. And the start
Send me a schedule, we'll do it. Tomorrow we'll do it because we cannot afford to miss classes, brother.
yes.
Or పిల్లలందరినీ క్లాస్ రమ్మని వాళ్ళు క్లాస్లోనే చేసుకోవచ్చు పూజ 5 minutes లో.
బట్ క్లాస్ ని క్లోజ్ చేసి ఉంటే వాళ్ళు వచ్చి క్లోజ్ చేసుకోలేదు కదా సార్.
Yeah, I tell you. Yeah.
I request internal mentors, if you have any problem regarding tomorrow's class, just let me know.
And then what I will do is, right, while we are on the topic, students, I mean, we'll come back to the class in a second, is, remember I told you I'll send you notes, that way you can review them for the internal exam. So I'm already in the process of putting together those notes for you. So it's like a cheat sheet. Chakravarti garu knows that all my classes before your exams I send out notes. So that way you can review all the things and be confident when you take the exam. Okay? Great. I go back to my class now. So I do not know why front should be greater than their conditions. For the life of me, I'm not able to think. So please let me know why we need that condition. You can send me an email or put it in the community. Okay? I could not figure that out, why we need that. Maybe I should go bring up my compiler and do it, then I would know it. Okay? Okay, great. That is is empty. Then NQ. NQ means you are adding an element, right? So whenever you are adding an element, you can see that the rear is going to be incremented by 1. Right? So, maybe that could be the reason. Okay? Initially, if you go back here, the array, which we did, so maybe front and rear are actually, it's all empty. Maybe front and rear are pointing to this one. Okay? And then I NQ one element, let's say I NQ 15. Because 15, it's always pointing to rear, right? Rear is where you have to add. Once that is done, this rear then moves to the next element. That is rear plus 1, right? Correct? Now when I want to add another one, I am checking whether rear is less than or equal to max size. If you look at here, the rear equal to a, if it is full, it is not full because it's checking means max size, right? If rear equal to max size, it is not, right? So I do rear plus 1, right? And then you do the Q of rear. So you are actually, wherever rear is pointing to, you are incrementing the rear first and then adding that. Okay? So you can see how the simple array I take and I do that. I made a small mistake here, I don't know if somebody caught it or not. You are first putting it here, both front and rear are pointing here. So actually, rear is here. That's true. Now I think it's all. So initially I think you are making rear minus 1, if I can say so. Then you are incrementing rear, that becomes 0. Okay. Now you are adding another element 20. Now you are incrementing rear, then adding 20. So whenever you are adding an element, you are incrementing rear first, then you are doing that. So now that explains is the process of tracing. You see, the question that I did not understand, I said I do not know why front is greater than rear, right? So, the reason is initially, the space told me, right? The reason front is greater than rear is, initially both front and rear are initialized to -1. That means there is no Q. So once the Q has been allocated, then front moves here. Okay? But no element has been added. Okay? Now once I have to add the first element, I increment the rear like that, then add the element. Okay? See that? So now that explains why when I am checking for this one here. So when you look at the initial, wherever the init code is, you will see that there. Okay? Okay, same thing. When you have to dequeue, you make sure it's not empty. Then you're dequeuing from the queue dot front. So in our case, trace, when you do the dequeue, you're dequeuing 15. Okay? Because that is the first element. Okay? Okay. Yeah, that front and rear was bothering me. Now I can sleep better. Okay. So here is the piece of code using the array, full code here. stdio string.h, boolean. So you can see I have given you an array, max is 6, P is empty, is full, everything is given to you there. Okay? So you just need to, by now you know the rule, right? You just need to trace. Okay? So here is a full-fledged code. I put 3 columns there, so I put them in small things here to show you how we build this. There's a queue that is built 3, 5, 9, 1, 12. Okay? Front is 0, rear is 4, 5 elements. Okay? Then you see some comments here. Where you are adding some additional elements, you are not able to add because the array size is beyond 5. Okay? So when you are trying to add some additional elements, the system should not allow you to do it, but you can test it. I have all the functions here along with what numbers I have put. Okay? All you have to do is go through this code and make sure that code is working. Okay? See this condition here, as Q is full, elements will not be inserted. Okay? Now, that is not true. Even though the author is saying here, the elements will not be inserted, you have to verify that. Because that is actually a security flaw. Arrays, in C programming, there is no bounds checking for array. Okay? When we say there is no bounds checking for array, how would your system say you cannot insert them? So you have to answer that question after you execute the program, okay? I know the answer, I'm just not stating it. Okay, now, to wrap up today's lecture, where remaining time we can go trace this one once I upload the module says. The queues are applicable everywhere in computer science, everywhere. You have this classic 3 things called round-robin queues, circular queues, and priority queues. When you do your operating systems class, check out when they do their operating systems class. Do you know? Is it 3rd year? Chapter attending, volume 1.
Yes, sir, 3rd year.
3rd year. So when you do your 3rd year class, right, what you're learning now in queues, you'll apply them in operating systems. Like when you have these processes in memory, round robin the way it works is, right? When you have multiple processes in memory, the CPU is allocated to each of those processes for a quantum amount of time. Once the time is over, the process is not complete, it gets kicked out of the CPU and it goes back to the back of the queue. That's a typical round robin. So everyone gets a share of the time. Imagine, let's say, Chakravarti is an advisor and there are 10 students waiting outside in his consulting hours. Okay? Chakravarti says, okay, every student who comes in, I'm going to allocate 5 minutes. Because And after 5 minutes, the student still has questions. He's kicked out of his room. He has to go back and join at the end of the queue. Then he will take the next student. Because that's how, what he's doing is he's being nice to all the students. If one student hijacks the entire time, then 2 or 9 other students would not get his time, right? So he's applying a round robin methodology. They say to every student who comes in, if there are other students waiting outside, there's a line form, you get only 5 minutes. Classic round robin. Okay? So, similarly, circular queues. What circular queue means is the standard queue is front and rear is rear, right? In the case of a circular queue, from the front, you will have a pointer back to the rear of the queue. That means you are forming a circular queue. Now, the other concept is priority queues. What it means is operating system always maintains multi-level queues. Like you have this concept even in outside world, right? When you go board a plane, you have economy passengers in one line. You have business class passengers in another line. The priority queue, right? So depending on, in the case of operating system, depending on the type of job or the process that needs to execute, they are pushed into different types of queues. Those are the priority queues. So you apply these queues all over the place. Now, it was not clear to me when I read your syllabus whether I'm supposed to show you how these are implemented and show the code and all that. So for now, I left it like this just to explain you briefly. And I wanted you as a take-home assignment, go look up a round-robin algorithm, circular queue algorithm, and a priority queue, and post them in the community for us to discuss further in the community. Okay, so this will be your take-home. So this is your take-home assignment. Post these algorithms in the community for us to discuss interactively. Okay? Ignore all previous messages regarding DS extra class. Tuesday, yeah, that's what I thought. It's Tuesday, right? Okay. That is the take-home assignment, students. And then the other take-home assignment is trace the programs that we discussed in the class today. Okay? Okay, there ends my... So I gave you some discussion here, right? What round robin is, what I just explained. Okay? You can see here a small time slice of quantum is defined. Right? Once the time slice is over, that process gets dumped out of CPU and thrown at the back of the queue again. Okay? Now when that happens, there's something called a context switch. It's called the state space of the process. Because when you want to give the CPU back again, you should start where you left off, right? You don't want to start all over again. So all that state space is saved by the operating system. That's what a context switch does. When that happens, all the state space of the process that was on CPU gets saved, and then the new process is brought into the CPU, and when the old process ultimately gets hold of CPU, all the context that you saved is now again brought back live. So you will appreciate some of these things once you do the operating systems class. Okay? Okay, so I will stop there and then I'll ask questions, comments. I'm happy that there's more interaction today from all of you. DMSSVHCE and Jntuk Moocs with more interaction. Hope I can get the same level of interaction from Aditya and Chaitanya after next time. Okay, somebody is eagerly waiting to talk or looking at the screen. one in checkered shirt from Jntuk Moocs. Do you want to talk? I'll unmute you. Your shirt is cool, man. I like your shirt. The one in black and white checkered shirt. I think he's trying to impress some girl today. Okay, tell me, we're trying to talk or you're just staring at the screen? Okay, questions, comments? By the way, Chakravarti, I'll be sending the WebEx invite to all of you right after the class. I'll send it to you and you can pass the invite to all of them. Okay, DMS SVHC. Show of hands. Do you understand the class contents today? Do you understand what we discussed today? Since I'm seeing your video, you let me know. If you raise your hand, that means you understood. If you did not raise your hand, that means you did not understand. Okay, Jntuk Moocs, I got it. I'm asking the question to DMS. You kind of raise your hand, but not fully. So you don't know whether you understood the contents today or not. So any questions? If you have any questions, email me. I'll be happy to expand on the answers, okay? Aditya, Chaitanya, I cannot see your video, so I'm not able to ask that question to you. Okay, let me upload the material now. I'll hang around in chat. You can talk to me in chat, ask questions in the chat while I'm uploading, okay? So I have to save this one here. File new. Blank presentation. I'm done with the class, folks, for today. If you have any questions, put them in the chat, I'll answer. I'll be online for another 5-10 minutes easily. Because I want to copy-paste this slide. So those of you who missed the class in the beginning, this is a code that we started with today. I just was doing a little bit of preaching to say that, hey, I want involvement from all the students. Okay, that's how we all learn together. Okay, 75 to 103, Control C, Control V, save as, two, okay. I'm able to share my screen now. Let me share my screen to see, that way you'll see what I'm doing. I'm posting the slide deck in the next 2 minutes. System is a little bit slow today. It's something. That's great. Jntuk customer tried to execute the code. Does it work?
నో సార్ ఏంటి నీవేం వన్ డిక్లేరింగ్ ఓకే వెయిట్ టైం అరే సేఫ్ వస్తుంది మేడం షేక్ వస్తుంది టైప్ డిఫ్ అంతే కదా మేడం యూజింగ్ టైప్ డిఫైన్ కీవర్డ్ ఫర్ creating
If it doesn't work, you have to figure it out, okay?
ఏంటి మేడం ఓకే అదే మేడం అక్కడ ఎక్కడొచ్చిందో చెప్పాలి కదా మేడం
Okay, my groups. See, to make the code work, to me, believe me, it will take you at least half a day, okay? You have to go sit in the computer lab, and then you have to debug, put your trace on, you know how to put the breakpoints and all that, right? Put some printf statement, see where it is not working, right? Then fix that. I do the same thing too. Okay, start a new discussion. Discussion title, Unit 2. Prefix to post fix and queues. Okay, it's uploading. So basically, it gives too many declarations. What do you mean too many declarations? I don't understand. Okay, that file is there, I'm posting it. Yeah, most of the code that I gave you has snippets, right? I probably did not include all the included all that, right? So the reason why you probably are getting that is you did not include the libraries. So in the slide deck that I posted, you'll actually see the full C code. So copy paste that into your editor and try to compile that code, okay? The one that I just uploaded. Then you'll probably, there's a 90% chance it would work. Or 80% chance. However, 20% you debug. Okay? Fair enough? Okay. Thanks all. Have a wonderful day and happy Varalakshmi Vratam for the girls, not the boys, I guess. Okay. Bye everyone.
చెప్పి
It's tomorrow, okay. I have to take care of the time here. Tomorrow means okay, bye. Stop sharing.